If you have a decoder that allows you to watch channel 1 to 32, or 1 to 5, if you subscribe to it, they send you a key. So before doing this, they have key, right? Okay, so if you have the right key as a decoder, then you could watch the particular channel, right? If you have, extensive net, viewing capability, you can watch all 32 channels, or whatever number of channels you have. But that's how they combine, a lot of movie together into your cable, which is the high bandwidth right here for your home. Okay, and then you have everything there. It's basically how you want to use it, right? DSL. Who has DSL? DSL, you have phone, data. You can have video, whatever you want to subscribe to, right? And in audio, you have multiple channels, and so on and so forth. So that's how they do it. For speech, they give you one channel. For music, they give you several channels combined together. For video, many more channels. Okay? So in DSL, you have 1024. And depending on your subscription, they give you whatever channel you have, and so on. Okay? Any questions? So I'll come back to this after the break. Okay? And then for questions. So it's good time for break right now. What time we come back? Tại mình thấy we see the example that we had before. There's a process of decomposition, right? Going from a high bandwidth signal into multiple signal with low bandwidth, right? And then we can combine them together to get to the original rate. The other problem of DSL cable and so on and so forth is the opposite. We first combine and we can decompose. But the setup is very similar. So what I'm going to do next is to focus the next hour or so on the properties of filter H, such that it can reconstruct. The idea here is that when we decompose, you want to somehow reconstruct back the signal. Okay? So you want it to be the reconstruction signal wideband is the delay of your input signal X. So the point here is, if you choose arbitrary filter here, this will not happen. So there must be some condition on the filter such that the output will be a shift of the input. Okay? If this happens, we call this perfect reconstruction. And in short, because PR, then for perfect reconstruction. The filter is designed such that the signal can be reconstructed from the output. Okay? So is that clear? So my next step I'm going to do is we're going to find the condition on the filter X K 0 and 1 and FK such that this one is PR. Is that clear? Okay. So we can, there are many ways of doing this. The easiest way is working in the Z domain or frequency domain. I hope you know what Z transform is. Okay? So we're going to be writing this in the Z transform domain. So let's do this step by step. If this is X of Z, what is the output here? H naught of Z, X of Z, right? The Z transform property is similar as Fourier transform. We filter, we multiply. Okay? And here we have H1 and X of Z. So what's the next step? We can look at this signal, that signal, or this signal and that signal. Now I leave it as exercise for you to look at this signal. But easiest way to do it is directly going to here. So tell me if this is x naught of z, x of z. What is that?
It's the same as x of z, not be x of z, but in even in every sample it was the same, but in the odd sample it will be equal to 0.
So let's call this u naught of z, okay?
Yeah.
And this one right here. And let's call this v naught of z, okay? Tell me how v and u are related. How does v naught of z or v naught of n related to u naught of n? Equal to u naught of n?
And is even.
Okay. Is that clear? So let's draw a drop diagram, right? This is u naught of n. Now by 2, v naught of n. I have to set u naught of n. Going through the cascade of downsampling and upsampling, you have v naught. What happened here? What do you get? 0, v naught of 2. Right? U naught of 4, and so on. What happened here? Insert 0 between the samples. Right? So you have u naught of 0, 0. U naught of 2, 0. U naught of 4, 0, so on. So how does v naught of z related to v naught of z? We done this before. U naught of z plus u naught of minus z. Right? E to the j omega minus phi is minus z. Is that clear? That's how we relate it. So if I plug this into here, what do I get? This is x naught x, z, x of z, and what is u naught of minus z? X naught of minus z, x of minus z. Any question on this experiment? Okay. How about the bottom branch? Only difference here is h naught replaced by h1.
Yeah.
Right, so I'm going to copy exactly the same form, replacing 0 with 1. Okay. So v1 of z is 1/2 h1 of z, x of z. Minus 3. Output is what? Output will be the product of f naught to that quantity plus f1 to that quantity. Okay. I will combine them all together into a big form y of z.